Welcome to the Explainer. Today, we're diving into Docker, a tool that has totally revolutionized how developers build, ship, and run their applications. It's a real game changer. Let's kick things off with a phrase that every single developer and probably every project manager has heard and absolutely dreads. You know the one. It's that classic line that just signals a world of pain, compatibility headaches, and long, frustrating nights of debugging. Well, that single problem, an application working just fine in one place, but completely falling apart somewhere else, is the exact reason Docker was created. It was designed to solve this dilemma once and for all.
So what's the solution? It's the container. The easiest way to think about it is as a standardized, self-contained little box. This box packs up your application with literally everything it needs to run. We're talking the code, all the libraries, the system settings, everything. And the beauty of this is that it guarantees your app will run the exact same way everywhere, from your laptop all the way to a production server. Okay, so that sounds great, right? But how do we actually make one of these magic boxes? Well, it all starts with a blueprint. Let's get into the heart of Docker, a simple but incredibly powerful text file called the Dockerfile. So this here is basically the recipe for your container. First up, from. This is like picking your foundation, say a specific version of Python or Node. Then you copy your own application code right into it. After that, run is for installing any dependencies or libraries your code needs to work. Expose is super important. It opens up a network port, kind of like opening a window, so you can actually talk to your app from the outside. And finally, CMD tells the container what command to run to actually start your application. The real magic here is that Docker caches each of these steps as layers, so if you only change your code, it doesn't have to reinstall everything from scratch. Trust me, it's a huge time saver.
Once you've written your Docker file, your blueprint, you just run this one simple command, docker build. This command reads your file and creates something called a Docker image. You can think of an image as a static, unchangeable template, the final packaged up result of all those steps you defined. Now, to bring that template to life, you use the docker run command. This launches a live running instance of your image, and that's what we call a container. This command also connects the internal port you exposed, port 5000 in this case, to your own machine so you can open up a browser and actually see your app running. But let's be real, modern apps are rarely just one simple service. What happens when you need a database, or a caching layer, or maybe another API? Trying to manage them all one by one with separate commands gets complicated and fast, and that's exactly where a tool called Docker Compose comes into the picture. So the whole game changes. We've gone from managing one single box to trying to coordinate a whole set of interconnected boxes. Your web app needs to be able to talk to your database, and they need to start up and shut down in the right order. This calls for a real orchestration tool. Docker Compose uses just one configuration file to define and link all your services together. It's like the conductor for your multi-container orchestra. In this file, you define your services, like web and DB. You tell it which image to use for each. You map the ports, and you can even create volumes. Now, volumes are super important. They're basically a persistent hard drive for your container, so your database doesn't just lose all its data every time you restart it. And here's the best part. After all that configuration, you just run this one elegant command. Docker Compose reads that whole file and brings your entire multi-service application to life, with everything connected and running in perfect harmony. It's that simple. Okay. So our application is containerized and it's running perfectly on our machine. That's awesome. Now, let's talk about the big picture. How do we get this thing out into the world and into production? This three-step flow is pretty much the modern standard for deploying apps. First, you build and test it locally, because you've got to make sure it actually works, right? Second, you push all your code and your Docker files to a repository like GitHub. And finally, your cloud server just pulls that code down and uses the exact same Docker static to build and run the application. This guarantees that what you tested locally is exactly what runs in production. No more surprises. Now, to really make Docker a part of your daily workflow, you need to get comfortable with a few commands. So let's quickly go over the 10 essential commands you'll find yourself using all the time. Think of these as your Docker toolkit, your Swiss Army knife for day-to-day container management. All right, here's your cheat sheet. You already know Docker Compose up to start everything and down to stop it. Docker PS is crucial. It just shows you what's currently running. Now, Docker Logs is going to be your absolute best friend for debugging. It lets you see the live output from inside any container.
If you need to poke around or run a command inside a running container, Docker exec lets you do just that. It's incredibly powerful. And finally, when things start to get a little cluttered, Docker System Prune is the magic wand you wave to clean up all the old unused stuff and keep your system nice and tidy.
So Docker and Compose are absolutely perfect for local development and for smaller deployments. But what happens when you're working at a massive scale? I'm talking hundreds, maybe thousands of containers running across a whole fleet of servers. Well, you're going to need a more powerful tool for that job. And this is where the orchestration giants enter the scene. You've got tools like Docker Swarm and then the undisputed industry standard, Kubernetes. They basically take all the core principles of Docker Compose and put them on steroids, enabling things like massive scale, automatic healing if a container fails, and updates with zero downtime.
So when you boil it all down, by mastering containers, you've fundamentally solved that it works on my machine problem for good. You've broken free from environmental limits, making your applications portable, reliable, and ready to scale. A whole world of possibilities is now open. So the only question left, really, is what will you build?